Good morning, students. Today we are going to learn the concept of address, data and control bus as well as tri-state logic. In the previous lecture, we studied the general block diagram of microprocessor 8086. So while studying that lecture, we have seen that block diagram, and that block in the block diagram there are different buses, and these are connected by the different devices. So you can see there is address bus, data bus and control bus. Now we are in this lecture, I am going to clear all the concept or doubts about the buses. So they are having the different names like address, data and control, and according to their names there will be the function of their particular buses. As well as in the few slides we are going to cover the tri-state logic. Now here I have shown the block diagram. In that block diagram you can see 8086 microprocessor unit and control unit mounted at the one side, and these three buses are connected through their like address bus, data bus and control bus. Now you can see there is address bus. Now what is the exactly the application or use of address bus? Okay, so address bus carries the address of the particular data or information. Suppose there is suppose you are living at your home, and if I want to reach at your home, so I cannot reach it at your home directly, so I need address, right? So how I can reach to your home without address? It is impossible. So if I want to reach at your home, I must know the address. Okay, so likewise this address bus carries the information of your data, or sorry, carries the address of your information or data. Now you can see the data bus. Now what is the data bus? Data bus is nothing but it carries the data from microprocessor to memory, microprocessor to input output, or both the input output devices. Now there is another is a control bus. Now the control bus is carries the control signal to the memory input and output. Now you can see the arrow of the address bus is only in the one direction, so means it is only in a towards the memory input and output devices. What is the meaning of this? So it only carries the information from microprocessor unit to the input output devices or memory. Okay, so whatever the address is take from the processor and it carries toward the memory input and output. Okay, so all these are nothing but what? One directional. Okay, or you can say that is unidirectional. Now we are moving towards the data bus. Now data bus is in the both direction. Okay, they having the arrow in a both direction, means it carries the data from memory input output through the microprocessor or from microprocessor to the memory. Now here is the memory block. The memory block shows the arrow in a both direction. Okay, arrow in a both direction means what? So it carries the data from memory to microprocessor or microprocessor to memory. So it is a both or bidirectional. Now input, you can see the input block only carries the information from input to the microprocessor. Suppose input is nothing but your keyboard is the input part, your input device, and suppose you press 1 plus 1, right? So you input this from the keyboard and now you are sending this data towards the microprocessor. That's why it shows the direction from input to the microprocessor. Similarly, at the output side, that arrow is toward the output side. Now I press the 1 plus 1 and monitor is the output device. That output device shows the result 1 plus 1 is equal to 2, which is shown on the output. So it carries the information from microprocessor to output, right? So the direction is the input from input towards the microprocessor, and for the output from output microprocessor to output. So it is a, we can say, the bidirectional. Now we are going towards the control unit. Now the control bus having the control unit toward the memory input and output. Now if you want to read something from the memory, so the control bus send the control signals toward the memory that I want to read the data. Likewise, suppose you want to write something into the memory, again it will send first the write signal towards the memory and it writes something into the memory. So read and write. Okay, so read and write, two signals can be given to the memory. Suppose in the input side, if you want to load something, if you want to increment, right, if you want to increment some value, so it again, this signal is sent by the control unit. Now I am going to explain everything very properly in the coming slides. Now address bus. Now in the 8086 microprocessor, address is a 20 bits. Okay, the address is a 20 bits, means there are 20 bits can be carried from that address bus, right? So there is almost, this is address bus, means this is location 1, sorry, this is location 0, 1, 2 up to location 2 raised to 20, that is almost 1 MB of the size of your memory. So it 20 bits means what? It gives 0, 0, 0, 0 up to 20 bits. Okay, so 0, 0, 0, then 0, 0, 0, 1, 2, 3 up to 1 MB. Okay, so this is nothing but what? The memory of your address bus or location. So if you want to take the information of bit number 3, okay, so it will come 0, 1, 2, so 0, 0, 0, and the last bits are nothing but what? 0, 1, 1, so 2 and 1. So this is nothing but location number 3, and you can take the data, whatever the data at location number 3, you can access that data. So this is how the address bus can access the data from the memory. Okay, now here, that is the unidirectional, means it only send the data from microprocessor to input and output devices or towards the memory. Now I have shown here the example. So 2 raised to 2 is equal to 4, 2 raised to 16 is equal to 65,536, and 2 raised to 20 is equal to 1 MB. So I have given here this is nothing but the examples. I have shown here the examples, that is 2 raised to 2 is equal to 4, 2 raised to 16, these are nothing but the bits. Okay, so this bits 2 raised to 2 is equal to 4 means, suppose there are 2 bits, so it can give the only 4 locations or 4 address or 4 memory locations. So this is nothing but 0, 0, 0, 1, 1, 0 or 1, 1, right? And likewise, this address bus shows the 2 raised to 20 is equal to 1 MB of addresses or memory. Now we are moving towards the data bus. Now it consists of 16-bit address line. So means each data or data of the 16 bits in bidirectional bus. So it is a bidirectional bus. Bidirectional means you can send the data and you can receive the data. On both the operations can be performed on this bus. Now you can read and write the data. You can both read and as well as you can write the data into the memory. Now this memory is having the different locations, and this location is nothing but your address. This address is accessed by your address bus. But the data is only carrying this data bus. Suppose this location, should be here, that I have we have studied in the last slide, that this is nothing but location number 1, location number 2, location number 3, location number 4, and this location number 4 is having the data of 16 bits. It can be anything. Okay, now if I want to access something from the memory, so I will first send the address from the microprocessor, and I will see what is the exact information to that address, and then I am carrying the data through the address bus. So I want to reach at particular location, then I will use the address bus, and by after the detecting that location, I am fetching that information using the data bus. Now it can read and write. It can read and write the data. So the number of data lines used in the data bus is equal to the size of data word. It can be read simultaneously. the many devices in the system will connect their output to the same data bus, but only one device at a time will have its output enabled, so that there is no data collision, or you can say contention. So only at the one time you can just connect the one device. If you connect the multiple device, there will be the collision, or we can say the congestion in the data. Okay, the data is also connected to the input output ports and the CPU, right? So we'll going to the next slide. That is the thing about the control bus. Now it is used to send the control signal or the memory, it sending the control signal to memory and input output devices. Suppose I want to read the data, write the data from the memory. So these are nothing but one of the signal. It is also input output read or input output write. Suppose there is a input, then it will take the write signal. There is a output, it can give the if it is the input, it gives the read signal. If it is the output, then it gives the write signal. Suppose there is a printer is nothing but the output signal or output device, so it will read the write the data. So according to different signals, the control signals can operate. Now tri-state logic output. Since we can have the multiple masters on a bus, we need tri-state logic for attachment to a bus, so that each device can choose to drive or not drive the bus depending on whether it is the bus master or a given bus cycle. So what is exactly the tri-state? It can be used sometime. There will be the signal, or it can be prevented from the bus conflict, where one device is driving a signal to 1 and another device is driving is to the 0 at the same time. So we generate the high current through the wires. Okay, so both one is generating, so both the devices are transmitting the data on a same signal or same wire, and sometime it is 1 or another device is 0, so there will be the conflict, so there will generate the high voltage. So prevention of this, for we are using the tri-state logic. So here is the tri-state logic and the buses I have explained. So here is the device and there is a block diagram, or you can say the circuit diagram. There is enable in and enable out, and it is connected to the bus. So at this one time you can just having the only one output to the device, output to the bus. So device can send the data. If enable in is there, then it given to the bus, or suppose there is enable out and then only it given to the bus. So at a time only one signal can be given. So the logical element has output enable pin to go from a floating output to drive the output from the circuit. So inverters and the buffers are used as a bus drivers or buffers. Okay, so it can be an inverter or buffer. So two such drivers or buffers in opposite directions are used to make the connection bidirectional. So you can receive or you can send the data over the bus. The gate also provide more drive onto the bus, so that the bus signals are stronger and the bus can be longer. So we can use the gate also. Now here I have shown here the tri-state logic exactly. The problem with the connecting the multiple normal outputs together on a bus is that each has to be in the logical state 0 or other 1. The driving voltage on which bus signal high or low. So these represent the conflict over the state of the signal. So we can resolve this by using the tri-state logic that I have shown here. So logically A and A bar, and we can attach the enable. If there is enable is on, then and then only it can be gives the output. If enable is off, then or it is enable is off, then it will not giving the output. So electrically I have shown here the 5 volt and output, right? So I have shown the diagram here. So in the truth table also, so enable is 0 and 0, it will not giving the output, or you can say the Z or high impedance. And now if you are giving the 1 and 1, enable is 1, then it gives the 1 or 0. So it is a bar, so negation is there. So for the 0, enable is 1, for A is equal to 0, so A bar is equal to 1. And if enable is 1, A is equal to 1, so output is 0. So this is what about the today's lecture. Very simple things about the address bus, control bus and data bus, as well as what is exactly the tri-state logic. So this is done for the today's lecture. Next lecture we are going through the on a Gmeet or maybe on a YouTube live. So if you have any doubts, you can clear, or you can ask in the comments, or you can simply message me or call me. So thank you very much for today.